Hey everyone, so I just found this interesting problem on the 2024 AIME 2, and I'd like to share a cool solution for it. So here's the problem, which was number 12 on the exam. Alright, so let's just draw this problem first on a coordinate plane. So we might try just imagining different segments of PQ as we move the endpoints around. And if we start with P at the origin and slowly slide it in the positive x direction, notice how the intersection of PQ and AB seems to move continuously from A towards B. However, according to the problem statement, there exists a point C that is not included in any of these intersections, as long as PQ is not equal to AB. To find this point, we simply find the limit of the intersection between PQ and AB as P approaches A. More intuitively, as P moves across the x-axis and crosses point A, notice that at the point where P is equal to A, the line segment rotates around a pivot point. This is the point that we seek. We find the pivot point through some simple calculus and trigonometry. Let P be m, 0 and Q be 0, n, where m squared plus n squared equals 1. Taking the derivative of this equation with respect to n, we have the following. At the point where P is equal to A, m is 1/2 and n is square root 3 over 2. So plugging those values in will give us this equation, which essentially tells us that point Q moves 1 over square root 3 times as fast as point P, when point P is equal to A. Looking at a graph of P and Q, we can draw in vectors for their velocities like so. With some trigonometry, we can find the magnitudes of the components of these vectors that are perpendicular to PQ, which gives us the following. Since P moves 3 times as fast as Q in the perpendicular direction, the pivot point C is located such that CP is 3 times CQ. Thus, C lies 1/4 of the way from Q to P, which tells us that point C is 1 over 8, 3 square root 3 over 8. Calculating OC squared using the Pythagorean theorem gives us this fraction, which implies that our answer is 7 plus 16, or 23. And that's it. Thanks for watching, and I'll see you guys in the next video.